Question 8, antimony has the atomic number of 51 and a relative atomic mass of 121.8. Define the term relative atomic mass. Another definitions question. 3 marks for this one. It's always 3 marks and they're always coming from the same place. But the words you've got to get in order to get the marks. So the relative atomic mass is the weighted mean mass. You don't need the word weighted, but you do need the word mean. Mean or average mass of an atom. I'm underlining those key words now that have to be in there. The mean mass of an atom compared to 1/12 of carbon-12. Okay, and those are your 3 marks. It's mean mass of an atom for 1 compared to 1/12. Let's put the 12th there. The second mark of carbon-12 for the third mark. Carbon-12, remember, is the standard that's used to measure the relative atomic mass. Everything is compared to carbon-12. And the last question, a sample of antimony with an atomic mass of 121.8 was analysed and found to consist of 60% antimony 121 and 1 other isotope. Determine the mass number of the other isotope in the sample of antimony. Only 1 mark for this, which is actually quite mean, I think. Like, this probably should be worth more, but so be it. The examiners have deemed it only worth 1 mark. So this is more difficult than a normal relative atomic mass calculation because you're having to identify or figure out how much one of these isotopes is, what the mass number of the other isotope is, rather than trying to calculate the actual final value. So all the ones you'd have done in practice would have been the sum of all the isotopic masses multiplied by the abundances all over 100 to give you this answer. So instead, we've got to work backwards. You've got to work with a little bit of algebra to figure out what your missing isotope is. So if we think of it this way, the atomic mass, remember, is equal to the sum of all the isotopes added together divided by 100. Okay, so that's my atomic mass. It's going to be equal to the abundance of one isotope, which is 60 times by 121, the abundance times by the atomic mass, plus 40%, so there's only one other isotope, so the other one's got to be 40%, multiplied by, I haven't the foggiest idea. So divide that by 100, and that completes the expression. So from here, you've now got an algebraic thing you can rearrange. So get rid of the 100. Let's work it step by step. Gives me 12180 equals 60 times by 121. Expand the brackets out. That's going to be 7,260 plus 40x. So I want to get x on its own. So it's just a case now of working through it. So get rid of the 7,260. So 12180 minus 7260 is equal to 40x. And then I want to get rid of the 40. So then if I divide that by 40, that will give me x. I'm just going to rub the 40 out there. So you work that out, 12180 minus 7260 over 40, and that will give you your answer of 123.